and it's got weeks in April. Now there's 17 students, and I don't know which days in April I'm going to be away. Right now, I'm not away any day in April, but they won't stay that way, I guarantee you, okay? So I figured I'd do up to 6 students each week for the first 3 weeks. We'll have a makeup week. I don't want anybody signing up for the makeup week. But if someone can't make it, or if Tom Eager can't make it 3 days, we ought to be able to do everything in 3 days each week, okay, to do 6 students. So which 3 days they're going to be, I don't know. Again, your presentation should be, if I tell you 10 minutes, you'll take 15, and then we still have another 5 or 10 minutes to discuss things, okay? If you don't care which week, it's okay. I would like everyone to come to class so that the people who are speaking have an audience beside myself and Dr. Belmar, but we'll do whatever we can. Any questions on the presentation? Most people will do it in PowerPoint. Some people can just use the board. If you want to use, like I do, but I'm the dinosaur around here, most people know how to use PowerPoint, okay? Have I told you about the evils of PowerPoint? Oh, okay. The Gettysburg Address in PowerPoint? Okay. Anyway, PowerPoint can be wonderful, but it also can be very, very sadly abused. The Navy calls it view graph engineering. You call it that in the Air Force? Yeah, okay. View graph engineering. So, and I may critique you on your view graphs, not to be mean, although I enjoy ridiculing PowerPoint. Not you, but ridiculing the mode of PowerPoint. But people have.
Some more animations and sounds we had today.
I was watching one of these faculty candidates had this little thing, and they looked like click buttons, and when she mentioned it, it wiggled. Like on your iPhone app where it wiggles when the thing's having problems, and it just bounced a couple of times. I thought, tacky. Okay. Hey, you can do these things. Yes, I don't care. Actually, I do like animations in the middle of PowerPoint. To me, that's one of the values of doing a PowerPoint, that you can actually show a short movie clip for 10 seconds or something.
I was thinking of text flying in from all directions.
Yeah, well, that's, well, I haven't given this talk, but I have given the talk to students before. I used to try to teach communications to freshmen. I didn't tell you about Lester Thoreau, did I? So Lester Thoreau, I learned in 1988 to completely revise the way I made presentations at conferences, and it has also influenced the way I teach, okay? I've always known that you can only get 2 or 3 ideas across in an hour, and it was a revelation for me in my junior year at MIT. I was taking a course I didn't have to take. I was a material scientist, and there was a course called 8 to 11 in the physics department that was a required course for certain people in electrical engineering, but it was for physics students or electrical engineering students. It was Introduction to Quantum Mechanics. Well, if you're going to understand how semiconductors work, you need to know something about quantum mechanics. I thought, oh, okay, I'll take this course. Well, it was taught by Vera Kistiakowsky, whose father, George, was at Harvard and had won the Nobel Prize in chemistry, okay? And Vera was a very strong-willed woman faculty member who always brought this big dog to class with her, okay? In any case, and she was actually a pretty good lecturer, but I didn't have a clue what was going on in this class. I was getting 15 out of 100 when everybody else was getting 85 on the homeworks, right? And I sort of barely passed a couple of the quizzes. So the night before the final, I just kind of took the book, Iceberg, Fundamentals of Modern Physics. I still have a copy of it. And I decided, okay, I'm just going to pick out the highlights of this course. And I sat down for a couple of hours, took out the highlights, went to the final exam, finished it, 3-hour final in an hour and 15 minutes, checked it over the next half hour, walked out and got an A in the course. And then I was saying, oh, all that other stuff is just fluff, okay? All you need to do is learn the high points. And so for the rest of my MIT career, both as an undergraduate and graduate student, I never really took a lot of notes, okay? And I don't really encourage you to take notes. I figure if I can't remember it, it's not worth remembering, and it's better to pay attention rather than my sitting there scribbling notes and not paying attention. So I would just sit there and I would try to figure out the professor's lecture outline, which was not always the easiest thing to do, okay? So I determined a lot of times the professors are trying to hide what's important from you. So anyway, and I actually did fine that way. I didn't have to study for quizzes anymore because I kind of figured out what the 2 or 3, at each lecture there's only 2 or 3 key points, okay? The last lecture I gave in here, I was talking about anisotropy, okay? And that you can have a different strength in plane strain than you do having uniaxial tension or something. And that leads to yield loci that are not a perfect Tresca or event von Mises condition, and that leads to differences in drawability. Okay, so there's kind of 3 points there in that whole lecture. If you can boil it down to the 2 or 3 key points, but usually the professors don't tell you what the 2 or 3 key points are. My problem in this class is I haven't lectured it for 30 years and I don't know what the 2 or 3 key points are. I'm just sort of doing this by, by feel. The next time I lecture this, I'll look through my notes and now they will be in more organized fashion. And I will actually, at the beginning of class, you might see this in the welding lectures, which I've given for many years, I'll go in and I'll put on the board at the beginning of each day. Last time, these were the key points, okay? So you need to figure out what the key point, try to figure out what the key points are if you're going to be quizzed. In this course, you're not even going to be quizzed, so who cares? But the point here is you can only get in 10 or 15 minutes about 1 key point across, which is why I want you to do a simple project, okay? I don't want you to pick something too complex. Okay, so the story with Lester Thoreau is, so I was taking the MIT Sloan School had a senior executives program, and Lester Thoreau had just become the dean at the Sloan School, and a couple of days before the Christmas holidays he sends around an email to all the faculty in the School of Engineering that any engineering faculty member who wants to take this 9-week intensive course starting in February, they would take one of the $50,000 tuition slots. Now this is 1988, so $50,000 tuition was a lot of money for a 9-week course. But these would be CEO type of level people that would come, and you'd live down at MIT Endicott House. Anybody ever been to Endicott House? It's this big mansion from the 1920s, French Renaissance mansion that someone donated to MIT. And so far as I could tell, I was the only faculty member in the School of Engineering out of 350 that applied to do this. And my department head was not happy at all because I was going to have to give up teaching my welding course that fall. But I was going to keep all my research going because I'd come in at 4 o'clock in the morning and get that stuff done, and I'd drive down to Endicott House and do my full day of things. And they actually would go from about 8 in the morning to 8 at night. And sometimes I would sleep down there rather than drive home. And we had to spend a week in Washington, D.C. I got to tour the executive office building, and you had people who were assistants to the president giving you talks about economics and things. Anyway, it was sort of interesting. But and then I learned a lot about, it was sort of a crash MBA, a 9-week. Harvard had a 13-week and still does executive management program. MIT had a 9-week. Harvard still has one of theirs. MIT now does little 2- and 3-day things. But in any case, Lester Thoreau came in to give a talk to us. He actually came in twice. And the first time, everyone knew Lester was this great speaker, okay? He called himself an economics educator. He wrote books that came in #2 on the New York Times bestsellers list. The one person who was ahead of him was Lady Diana's book, okay? He said, "Never compete with a princess," was his little catchphrase there. Anyway, Lester was getting $30,000 a lecture to go to some boardroom and give a talk to the board of directors of some company. You know, I thought that's pretty good money in 1988. Not bad today for a 1-hour lecture. But he was just a very engaging speaker. He never used overheads or anything else. He just would have a little 3x5 card with a few words written on it. And he would just talk from whatever he knew. Now he had his little outline. And so to a certain extent, I now use Lester's technique. I mean, I have, pages I put together, but this was not part of what I was planning on talking about. But anyway, the first time Lester came in, all 50 of us, and we're talking about many of the people in the room were CEOs of billion-dollar companies. And 2 of them were not CEOs, they were managers. They worked for General Motors. And at General Motors, if your title was manager, you ran a billion-dollar business. One of the guys was in charge of all the lights in automobiles. They made, his part of Delco made all the lights for all the General Motors vehicles. That was a multi-billion-dollar business. But he was a manager at General Motors. That was, he didn't have a big title, but he had a lot of responsibility. And I was 38 years old. There was one guy from Xerox who was 33. Everybody else was probably post 45 in this class. Anyway, so Lester comes in. He gives this wonderful talk. Everybody's just enthralled, including me. So about 4 or 5 weeks later, Lester comes in a second time to talk to us. And everybody else was just enthralled again, but I'm the engineer sitting in the back, and I'm trying to figure out why was Lester so effective as a speaker. And after it was all done, I realized he didn't say anything I didn't know, but it was the way he said it, okay? And I realized that going to conferences and in class, I was doing it the wrong way. You've got to say things in nice little sound bites that people will remember, okay? And the example I give, a few years later, I was listening to Lester talk over here at the Marriott Hotel to a bunch of people. And he was still the dean, and he was lamenting that the business school up the river, with all their money, tends to hire away some of the best faculty from MIT. And everyone sort of knew he was talking about Robert Merton. Anybody know who Robert Merton was at the time? Or is, I guess he's still alive. Robert Merton worked for Black and Scholes, who were the guys who came up with the algorithm for derivatives, which also brought down the world economy, which is another story if you want to talk about 2008 crash and why it occurred. But it was derivatives. It's a big Ponzi scheme. Well, the derivatives are a way mathematically to predict what you expect the value of something to be in the future. And we can talk about how they were abused by all the people on Wall Street and around the world, in London and other places. And that was what caused the financial collapse. But it's not the derivatives are a bad thing. But anyway, it had changed the whole world of finance. And Black and Scholes were the faculty. They passed away. But Merton won the Nobel Prize when he was at Harvard for this, okay? So it's fairly well-respected thing, okay? But Lester's describing their Harvard hiring away some of our best faculty, but he said, but fortunately, they tend to hire our extinct volcanoes, okay? Isn't that a great metaphor? No one has to explain what you mean by an extinct volcano, right? When you're talking about some academic, right? So I learned from Lester that sound bites were good. Now you also have to understand Lester's colleagues at the Sloan School used to call him, and in the Department of Economics, used to call him less than thorough, okay? Because he didn't really worry about all the facts, okay? He just told a good story, okay? Very engaging storyteller. And I actually thought it would be even better if I had sound bites, but with some content, okay? But Lester wrote some great books. His other great love was hiking in the mountains, but anyway. And so about a year later, it was around 1990 or something, I was at a conference and I had to give the keynote speech at some welding conference, and I was talking about resistance spot welding. And I said, they put 3,000 spot welds in the average automobile because they need 2,000 good ones, okay? And I had a nice PowerPoint slide. Actually, it wasn't PowerPoint back then. I had a slide of that. And a year later, I'm at a welding conference at a cocktail party, and I hear someone behind me say, did you know they put 3,000 spot welds in the average automobile because... So they're quoting the soundbite. If you can learn to speak in soundbite, you can be president of the United States, okay? And you don't even have to have content to your sound bites, okay? Mine actually had some content. But in any case. But it changed the way I'd give talks. It changed the way I taught. And you need to think about it. No one ever explained to me as a student that how important being able to get those things across is. And I did talk to one of you going out of class the other day You know, I don't spend a lot of time on a lot of math because I think I told you at the beginning of the class, you're MIT students. I can assume you can do the math. But what you need to know is the physics. And most of you had never thought about biaxial loading before, okay? So we're going to talk about biaxial loading today. And so I just killed the first 20 minutes of the class talking about other things. But it wasn't killing it. Actually, was probably more useful to your future career than if we had talked about biaxial loading, because come on, give me a break. How often are most of you going to have to worry about biaxial loading? But that's what this part of the course is about, so we will talk about biaxial loading. And we had talked about, starting to talk about deep drawing, because the R value, the anisotropy ratio, you can get a shallow draw or a deeper draw before you start to get fracturing down here. If you don't have enough pressure on the top, you can get wrinkling, you can get earring, and we were starting to talk about earring. Earring can occur at 45 degrees or at 90 degrees to the rolling direction. So that's why they're showing these. This is 45, this is no earring, and this is 90 degrees. I showed you those before. And this is what I would have shown you if we hadn't run out of time. And this is out of Hosford's book. Oops. For steel, copper, and aluminum, all these things plotted as percent mean ear heights. And some of them are taken as negative because their ears at 45 degrees and the ears at 90 degrees are considered positive, and the ears at 45 are considered negative. And if you plot it as 2 delta R over R bar, as he's defined things in here, there is a very good correlation between the anisotropy ratio and the extent of earring. And we talked about that in terms of the texture that's developed in sheets. Okay? So I needed to finish up that on earring. We're done on earring. So you want a big R value, but you don't want a R value that is too asymmetric in different directions, or you just end up with ears, and you can draw, but you're gonna have to cut off the top portion because of the ears, unless you like ears. Okay, but that's a different type of ear. Now I want to talk about the limiting drawing ratio and tell you the story I told you I was going to tell you about an auto crash in California. Anyway, the limiting drawing ratio, you plot the major engineering strain versus the minor engineering strain. This is the strain in the one direction versus the strain in the two directions. So we're talking biaxial loading here. Uniaxial loading would be 0 on the E2 axis. And this would be your typical maximum value you might get, and this is for steel, it turns out. You might get about 30%, this is about 28% elongation before the thing starts to neck down and create problems. And so don't worry about diffuse necking. This comes out of Hosford. We're going to go over necking theory and either on, well, probably next week. But don't worry about the necking theory where some of that comes from. And then this is the experimental forming limit. They actually, if they do things well, they can get more than the tensile specimen uniaxial tensile elongation ductility. You actually can get up to over 40% stretch, even uniaxially, as you're bending over corners and getting work hardening and other things. But in fact, if you add some biaxial side strain in tension, this thing goes up to almost over 55%. If you give it some squeeze in a plane strain towards plane strain, you can start getting very high effective strains. So your drawability is much different than what you would get out of a predicting ductility from a uniaxial tensile test. In your whole drawing operation, remember I showed you that on the flanges of the draw, you might have plane strain, and then down here in the wall you have a different condition. I can't even remember what it is right now, but you have different biaxial loading conditions on the wall versus on the flange. Okay, and I gave you a picture of that, and I'm sure it's in Hosford. But this is what's called the limiting drawing ratio, or the forming limit diagram. And again, this is low carbon steel. Why does everybody do low carbon steel? That's what you make automobiles out of in general. So you can see again a little over 30%, and you can go up to over 100% strain if you give a little side squeeze. If you give a little side tension, you still get an improvement. The worst condition is the uniaxial condition. So the tensile test is giving you the worst thing, and the open circles are successful draws and the closed circles are unsuccessful draws, where you got necking and things started to break on you. Okay, so that's the forming limit diagram. Now let me tell you a story about the forming limit diagram. So there's this problem. California has much more stringent environmental laws than most of the rest of the country, because let's face it, they're 18% of the U.S. economy. And some people say, well, actually, they're 18%. They're also, if they were a nation unto themselves, which they sort of think they are, if you ever talk to some people from California, they would be the 18th largest country in the world economically. Okay? So they're pretty dominant in many ways. And so California will lead the nation as environmentalists and in such things as saying, we want to have partial zero emission vehicles and things. And let me close that down some so you can see the photo here. This is a situation that in the early 2000s, California had requirements that were stiffer than the federal government requirements for the total hydrocarbon emissions from a gas tank on a vehicle. And back in the 1980s, people used to use turn plate for making gas tanks. This was low carbon steel. Anybody know what turn plate is? It's lead coated steel. Just like galvanized steel is zinc coated steel. If you lead coat it, same type of thing, just pull it through a lead bath. And if you do it with the right flux and stuff, you can get a lead coating. Lead has outstanding corrosion resistance in hydrocarbons, in water, and everything else. The roof at Kresge Auditorium has got a lead membrane on it. Okay? The water pipes, when they first started piping water through London, were lead pipes.